Welcome everyone. In this video lecture, we will solve a problem based on diode and it is from the Microelectronics circuits book. So the question is for the rectifier circuit shown below. So this one is basically a half wave rectifier circuit with a input sine wave 120 volt RMS. So the V RMS value is given 120 volt. Okay. So and the assume that the diode is to be ideal. So this one is basically ideal diode. So select a suitable value of resistance R so that the peak diode current does not exceed 50 milliampere. So the I value will be maximum 50 milliampere in the circuit. So this one is the uh, question. Okay. So VRMS is given. So if we draw the sinusoidal curve for this Vs, so it will be like this. Okay, Vs is like that. Okay, so this peak value, or sometimes we can say Vm and minus Vm. Okay, or V peak value, Vm value will be the maximum value. This maximum value will be V RMS into root 2, or this one is a V peak. Peak to peak will be 2 Vm here, so it should be 120 into root 2. Okay, so this value will be 120 root 2 minus, and this should be minus 120 root 2. Okay, so this one is the given term. Okay, and this is a sinusoidal signal. Okay, so now we have to find the resistance R. So when diode is operating in between 0 to t by 2, say when the time interval 0 to t by 2, the diode will be in the on state. Okay, that means this diode will be short circuited. So one can read over the circuit like this. So this diode, okay, or before that I am just making how to solve, and the maximum voltage that we will give as a DC, because this will be plus 120 root 2, 120 root 2, and this will come. For simplification purpose, we are just saying the maximum voltage, DC voltage, will be like that. So during this positive voltage, this diode will be shorted. Okay, and this will be R, and this will be 120 root 2. And it is clearly given the I value will be 50 milliampere. So the value of R can be calculated very simply. V equals to IR, or you can apply Kirchhoff's voltage law. So the R value will be V by I. So maximum voltage, which is basically 120 root 2. That's why I'm just, for the convention, for the simplicity, I'm just putting a DC. Okay, so it should be 120 root 2. Okay, and then after we have to divide with I, that is our 50 milliampere. So 50 into 10 to power minus 3, or we can do like this, 12 root 2 by 5, then into 10 to power 3. So if we solve this one, okay, if we solve this one, the overall value I have already calculated, 3.4 kilo ohm. This one is kilo, and 12 root 2 by 5, it will come around 3.4 kilo ohm. So the resistance value, R value, will be around 3.4 kilo ohm for the current 50 milliampere. So now next we have to find the what is greatest reverse voltage. So greatest reverse voltage is nothing but simply peak inverse voltage is our peak inverse voltage. For the calculation of reverse voltage, what we have to do, we can say for the reverse voltage we have to give a negative voltage. Okay, say this minus plus, and then I am saying that this one is minus Vm. Okay, maximum reverse voltage and during the reverse voltage the diode will be open circuited, okay, and there will be no current in the circuit, okay. This R and the current, if we apply from Kirchhoff's voltage law or KVL in this law, and this value is nothing but simply VPIB. Sometimes it is say peak inverse voltage. So in a half wave rectifier, we know the peak inverse voltage is Vm. So this can be simply obtained by just applying plus Vm minus VPIB equals to 0. So VPIB equals to Vm. Okay, so Vm is equal to 120 root 2. So it should be around 169.68 volt. So this one is the peak inverse voltage or maximum reverse voltage that a diode can be tested. So this can be easily found by giving the polarity change. So minus plus Vm, this would be minus, the diode will be open and the current will be 0. So there is no need to worry about this one. So plus Vm minus VVIB equals to 0 by applying KVL should be 169.68 volts. So the correct answer for this question, the peak diode current resistance to suitable value of R. So this R value is here 3.4 kilo ohm, and the reverse voltage, okay, that reverse voltage is around 120 root 2, that is our 169.68 volt. So this is all about this question. This is a very simple question and it is from the microsecond. Okay, so this was the simple half wave rectifier. So the peak inverse voltage is also Vm. So this is all about this question. So thank you for watching this video.